Welcome back to the second part of algorithms. So our next topic will be applying algorithms in C. So we were gonna look on how we can apply algorithms in C code. So first, um, we will discuss how to write a selection sort algorithm in C. Um, it's important to note here that algorithms are meant to be abstract, meaning that this algorithm will be able to work with any numerical array. So this algorithm will work in any on any array. So remember in the previous video we discussed how array works, but later on we will discuss that further. So that's just an introductory. But here's an example of an array and how we use algorithm. So in C, we initiate an array using int if the type of value is an integer, and then we define that. So after that, we use a for loop to find. We start with the index 0, and then we if the index is less than test array length, which is this is the length 1, 2, 3, 4, 5, 6, 7, then it increment by 1, and then we write that in the console. With this knowledge, you know that once the first item is found and moved, the value at index 0 is sorted, and the algorithm doesn't need to visit the value stored at the index anymore. So in the previous video, um, the selection or the selection sort stop once the value is found. So it's the same for any algorithm. But uh, I just want to add here that in the previous video we discussed mainly the thesis or the theory about it. Now we will actually gonna apply it. First, this will be the case for each subsequent sorted item. Second, how can we search through the unsorted part of the array exclusively so that we don't waste resources visiting sorted items? So for selection sort, we need to worry about not wasting resources by checking the items that we have already checked. So we need to think about that when writing in C. So I know it's kind of complex to understand this at this point because we're actually using this toolkit. So before we just use a pseudocode or manuals. So the library just use a manual or pseudocode to like think about how it will use the tool to apply the algorithm. So this algorithm, think about this as a librarian wants to sort the books by its count, by each page count. So it will find the smallest or the thinnest book and then place that at the first so that moving forward, it will be easier to search for books. So this is like a selection sort uh, with a library metaphor. And then third, we can use a technique called nesting to do this, where we can insert an additional for loop within the first for loop and search through the unsorted section. So the way we avoid wasting resources or for checking the books that we've already checked is using nesting. So we've discussed in the previous full stack web development how nesting works. Nesting basically nest from the word nest. I would recommend you going back to the previous topic about that, but I will provide an example here. So we within nesting can be a useful tool in building algorithms and can be used with other statements such as if else. Let's use nesting here by adding another for loop. So here's an example. For the previous example, we initiate a test array and then we created a for loop and then we can write it on the console. Here, within this, so within this code, we actually have another for loop here. For unsorted index equal index plus 1, if unsorted index is less than test array dot length, then we will increment it again. So once we found the a thin book, once a librarian found a thin book and was able to sorted some of the books by its page count, it doesn't need to go back to that list again because the librarian or she already found the thinnest book. So she only need to go to the library and find the next thinnest line or the next or the higher page count that she can add to the bookshelves. So here's the example. So I just forgot to indent it. So guys, when building code, I would recommend you indenting it for easy readability. Now, after we increment that, we write unsorted value plus test array unsorted index. So that's what we write on the console there. So it's easy now to read. Now, this inner loop is visiting. Let's just fix this. This inner loop is visiting the unsorted parts of the array by increasing the current index by 1. The loop starts by visiting index 0, then visiting all the items at index 1 to the end. So it starts with 0, and then once it got the value at 0, it moves to 1, and then until the end. So the algorithm is incomplete as is, but the goal is that when the smallest item is placed at index 0, the inner loop will visit all items starting at index 1, finding and placing the smallest item at index 1, and moving on to the next item until it reaches the end. So that's what the librarian does. Once it found the smallest, it will move to the next smallest, and then next smallest, etc. Third, at this point, it sounds like the algorithm will need to make some comparison within the array to find the smallest value and the index of where it's stored, which can be captured in a variable. Now, after we do that, the algorithm need to make some comparison to find the smallest value. So once we found the smallest value, we need to compare the that smallest value or the next smaller value is greater than the smallest value because it could not be lesser because it's the smallest. So in that case, we can use a variable to compare that. We can use the index variable to keep track of the index and use it to find the value stored there. Here's a snippet of the outer loop and the values to keep track of. So here, we start with index 0 and then we increment it. Now we create integer minimum index equals to index and then minimum min value equal test array then index. So again, remember when creating a variable, always make sure that it says what it does to be readable. First, now that we are storing the key values we need to keep track of, let's compare the value to the rest of the unsorted array with an if statement. So now we have these variables. We can use an if statement to compare that with the remaining unsorted values. So the remaining unsorted values should be greater than the smallest value. This should happen within the inner loop as it's visiting the unsorted values within the array. Here's a snippet of the inner loop and the comparison. So here's the inner loop and its comparison. So for an unsorted index, equal index plus 1, which is what we had earlier. If test array unsorted index is less than the mean value, which is this, then mean index equals to unsorted um, index, and then mean value equals the test array unsorted index. So here's another. So if this test array unsorted index is less than the minimum value, then here's the value of mean index is equals to unsorted index, and the value of mean value is test array unsorted index. So here, the initial value of mean value is test array index. But if test array unsorted index is less than the mean value, then the value of mean index is now unsorted index, which earlier is index, and the value of mean value is test array unsorted index. And then third, when a smaller value is found, it will replace the currently stored index and value and keep going until the smallest value is found within the unsorted part of the array. So for the unsorted index, so let's say you have like a million books. The library found the smallest. So it took a while for the librarian to find that because there's a lot of books. For the remaining books, it doesn't need to find the smallest book because that's the smallest already. It needs to find the next smallest book. Now, in order for the librarian to avoid looking at that smallest book again, let's say it's on the other corner of the library, here, another corner of the library, and here's the librarian, then it doesn't need to check this. It only needs to check this. So the way to do that is using this variable. So when a smaller value is found, it will replace the currently stored index and value and keep going until the smallest value is found within the unsorted part of the array. So that's what it does. So that's what it means, default. Might looks complex, but that's simply what it does. At this point, it's now time to swap the smallest value with the value of the index stored in the index variable if it exists. So here's the code, temp value equal test array index, and then test array index equals test array mean index. So what that means is that first, the index variable is the location of the value that needs to be swapped with the smaller variable. So the index variable is actually the location of the value that needs to be swapped with the smaller variable. However, we need an extra variable to store the old value of the initial location in a temporary variable. So we need to store the old value. So let's say we're finding the smallest books, the next smallest book here in this library. So let's say we found a potential smallest book. We put that in this like here. We put that here, and then we go to the next shelves, and then we put that here, and then we compare these books. So that's basically what it does, which is the variable called temp value, so that the next line can swap the two values by replacing the current value of the current index with the newly discovered minimal value at mean index. Finally, we use the temp variable to store the previous value in the next index variable. We set it to the old location of the uh, minimal value. So here. um, the the test RA mean index becomes the new temp value. So basically, this is the whole code for easier grasp of this. So let's say in C, we're using system, and then the name of the class is program. So we start with an array, and this is the selection sort algorithm. We start with for int, it start with 0, index less than test array dot length, we increment, and then the initial value of mean index is index, and then mean value equals test array, and then index. So for unsorted index plus 1, we increment again, and then we change the value of the mean index to unsorted index. And then after this, we have an issue of like storing the books here. So we swap the values. We use if statement again. Mean index not equals to index. So int type value equals to test array index. Test array index equals test array mean index. So here we're basically changing the value of test array mean index to temp value, and then we output the array. So what if we output that, this what will show 0, negative 4, 7, 13, 20, 55, 80. So let's try this code on a C runner. So here you can go to https.net, fidel.net, and then when you copy and paste and run, you see negative 4, 0, 7, 13, 20, 55, 80. So that's how we do or apply the selection sort algorithm. Now we'll move on to writing a linear search algorithm. In the previous algorithm, selection sort, a linear search already takes place where values are compared with less than comparison operator to find the lowest value. So in the previous selection sort, we already use the less than comparison operator to find the lowest value. We will also apply that in this linear search algorithm. So the basic version of linear search only needs one loop, and we'll use the equality operator to find the value. If the loop reaches the end of the array, then the value does not exist within the array. Let's build a short example of linear search within an array. So let's say there's a reader finding a book. So if that book exists, the librarian will be able to return it or to give it to the reader. But if it doesn't exist, the librarian will say that the book is not available here, it may be on another library, etc. But basically, it did not found, she did not found the book. So here's an example. We start with array again. So again, array is a way of defining variables, multiple variables. It can be used to define multiple variables. So here in search value starts so the search value here is 0. So we're trying to find 0 on this array. So for int index, so we use a for loop again. So we start with 0, and then index, if it's less than, we increment. So basically it's just a for loop formula. If search value equals to test array index, then we write a value from and then break. So when we run this, it will return a 0 because it found it the because the system found it, right? Oops, there's a compilation error. Let's search it. So here is actually the right value, guys. So in array for in search value, let's run this value found. So again, so ChatGPT told us the issues with the misplaced curly bracket, which makes syntax invalidancy. So that's how we do the linear search algorithm. That's the basics, the most basic. So it's shorter than the selection sort because selection sort actually needs to find all the values in the or yeah all the books in the library and then sort it out. Well, this it just needs to find one value. This algorithm will need to look to visit each item in the array so that the value being searched for in search value in this example is compared for equality in an if statement. So it will loop until it equates with the value, which is the search value. So if this search value is equals to test array index, so test array, which is this, and then index is like the, the index because we've discussed that in the previous video, but we will discuss that further in the next videos. But if the value of that match, then it will return value found. So when a value is found, the search is over and the loop should end. Loops can be interrupted and exited with a break statement inside the code block. So it can be interrupted by this break statement. If you run this example as is, the output to the console will show the following message: value found. This message prints because the value of search value is 0, which exists in test array. So in the next video, we will discuss writing a binary search algorithm. So basically, if the value is higher than the midpoint, the algorithm narrows the search to values to the right of the midpoint, known as the upper half. So the upper half is basically this for this array. So anything that's to the right, and then to the left if it's lower, known as lower half. So this binary search assume that this array is already sorted. So let's say this, let's make it 0, and then make this 13. Let's make this, oops, yeah, 13, then negative 4. Oh, yeah, it's actually negative 4 here. So basically it's sorted, guys. So what binary does is that, oh my god, so I think so it should be 7 here, and then 13, 13, 20, 55, 80. So once it's sorted, it will check if the value that it's finding, uh, let's say it is looking for 7. So if that value is less than the midpoint, it will go to the lower half. So let's say it's looking for 55 and it's lower than 13, it will go to the upper half. It will not search everything. So it's faster for large data sets. So we've discussed it in the previous videos. That's just what we will do in C as well. So again, guys, thank you for watching and see you in the next video.